Joe Rogan uncovered the stunning picture taken by the James Webb Space Telescope, which at last showed what Oumuamua resembled. Astronomers found a strange object traveling through the solar system in 2017. The first known interstellar object to come to our planet is Oumuamua. However, could these images alter everything we know about the universe? What did the photographs of Oumuamua reveal about its true nature? Find out what this interstellar visitor has to say about the world beyond our solar system by delving into the specifics. In 2017, the Pan-STARRS 1 telescope in Hawaii, which is known for observing strange events, made a startling discovery. The first known object to visit our solar system was Oumuamua. Its revelation brought up many issues among researchers and fascinated nearly every individual who found out about it. The James Webb Space Telescope has now captured a surprising image of Oumuamua, revealing its true form. This object provided evidence that objects outside our solar system could roam freely. Oumuamua is remarkable not only because of where it came from but also because it has very different characteristics from comets and asteroids. The majority of space rocks we encounter have a round or irregular shape. However, Oumuamua is a long, thin rock that is only a fraction of a football field wide but the length of a football field. Its path through space suggests that unlike the majority of space debris, it was not captured in orbit around the Sun. The absence of a comet tail is one of Oumuamua's most puzzling features. Most comets have a tail of residue and gas limping along them, yet Oumuamua doesn't have one, despite the fact that it came extremely near the Sun. This is a significant indication that this is not a typical asteroid or comet. Oumuamua's arrival is unprecedented. Its starting point, strange shape, and startling way of behaving have provoked researchers and space devotees the same to inquire. What precisely is Oumuamua? Where did it originate? Furthermore, what can we learn about the world beyond our solar system? The James E. Webb Space Telescope, which got its name from him. Webb, who served as the initial administrator of NASA during the Apollo missions, is an essential instrument for space exploration. This telescope addresses a jump in our capacity to notice the universe, imagined in the last part of the 1990s as a replacement to the Hubble Space Telescope. It was made to look into the universe more deeply than ever before. The James Webb Space Telescope was designed to answer important questions about the stars, the first galaxies in the universe, the formation of solar systems, and the possibility of life elsewhere. It was constructed through international collaboration led by NASA with significant contributions from the European Space Agency and the Canadian Space Agency. The telescope's suite of cutting-edge instruments and a massive 6.5-meter primary mirror made of 18 gold-coated beryllium hexagonal segments are at the heart of its capabilities. The telescope is able to gather more light and observe objects in greater detail thanks to this mirror, which is significantly larger than Hubble's. The telescope's design makes it possible to observe in the infrared spectrum, which is necessary for going back in time to the first galaxies that formed after the Big Bang because the expanding universe stretched their light into infrared wavelengths. The near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor/near-infrared imager and slitless spectrograph are the four primary instruments that make up the James Webb Space Telescope. From capturing detailed images to analyzing the chemical composition of celestial objects, each instrument performs a distinct function. The telescope's ability to observe the atmosphere of exoplanets, potentially identifying signs of habitability or even life, is one of its most groundbreaking features. The telescope is able to detect chemical signatures that may indicate the presence of water vapor, carbon dioxide, methane, and other important molecules by analyzing the light from stars as it passes through an exoplanet's atmosphere. The James Webb Space Telescope faced a number of obstacles on its way to the stars, including technical difficulties, budget overruns, and delays. However, on December 25, 2021, the telescope was launched from French Guiana aboard an Ariane 5 rocket after years of meticulous planning, construction, and testing. After that, the telescope set out on a journey that lasted for a month to reach its operational orbit at the second Lagrange point, which is about 1.5 million kilometers from Earth. There, it is protected from the heat and light from the Sun and has a clear view of the universe. The James Webb Space Telescope has begun to live up to its promise ever since it was launched, providing stunning images and data that are reshaping our perspective on the cosmos. Past accomplishments include taking precise images of far-off galaxies, observing the atmospheres of exoplanets,
Liftoff
and peering
of
into the
the
dust
Delta
clouds
rocket
where new
carrying
stars and
GLAST,
planetary
a gamma ray
systems are
telescope
created.
searching
The
for
James
unseen
Webb Space
physics in
Telescope
the
was the
stars
best
of the
tool for
galaxy.
getting a closer look as Oumuamua entered our solar system. It was able to gather information about Oumuamua's shape, size, and structure that no other telescope could because of its array of instruments and focus on infrared light. The telescope's assortment of perceptions of Oumuamua is a significant space project. Space enthusiasts and scientists are eagerly awaiting the telescope's findings. By providing insight into the fundamental components of other solar systems, the findings could have broader implications. Scientific debate has focused on Oumuamua ever since it traversed our solar system. At first, some people thought it looked like a long, thin cigarette, while others thought it looked more like a wide, flat pancake. In order to comprehend its journey through space and the forces it encountered, it is essential to comprehend Oumuamua's shape. The formation and origin of Oumuamua have been the subject of numerous scientific speculations. One hypothesis recommends that a lump of nitrogen ice severed from a Pluto-like world in a far-off star framework. This would shed light on its original star system and explain its unusual acceleration as it passed the Sun. The possibility that Oumuamua is an artificial object, possibly a probe sent by an advanced alien civilization, is one of the most talked-about theories. The hypothesis is powered by its surprising speed increase, which a few researchers contend could be characteristic of a light sail, a slender, wide surface moved by sunlight-based radiation. Despite the fact that this theory lacks concrete evidence and leans more towards science fiction, it highlights the influence that Oumuamua has had on our imagination and our desire to connect with other intelligent life in the universe. Oumuamua could be a planetesimal from another star system or a fragment of a broken planet, which is an intriguing possibility. This hypothesis suggests that Oumuamua might have been a section of a bigger heavenly body, potentially destroyed by enormous powers during a nearby experience with a star or huge planet. This event may help shed light on the violent activity that takes place in solar systems by providing an explanation for its extended shape and unusual orbit. The real essence of Oumuamua stays hazy. With something as bizarre as Oumuamua, it's easy to form opinions, even though each theory adds to our understanding of the universe. Although Oumuamua is indeed odd, it is not scientific to jump straight to external explanations without solid evidence. Keeping an open mind while remaining grounded in scientific inquiry is essential. The new picture taken by the James Webb Space Telescope has the logical world invigorated. We were able to get a close-up look at an interstellar object that was passing through our solar system for the first time. This picture shows Oumuamua as a one-of-a-kind, fascinating object with its own features and characteristics. We now have our first look at an object from another star system thanks to the unprecedented level of detail compared to previous observations. Many of the theories about Oumuamua that have been proposed may be supported or challenged by this image and the data that goes with it.